Using trig to solve word problems with two right triangles. All right, so this first one really isn't like a word problem, it's a diagram problem, but close enough. Here we've been given a diagram that really has three triangles. It has one here, and one big one out here. And we have four different side lengths we're trying to find in it. We've been told that x plus y is 27 and round our answer to the nearest 10. So when I'm looking at these, and you can assume that this is a right angle, but don't assume any other things are right angles here. So you can assume this right angle. Um, so we looking at y and u, there is nothing I can do about y and u because I don't know any of the acute angles in that triangle. I don't know any of the side lengths. So u and y are off the table for now. X and w, I can both solve using trig. I have enough information for that. So we're going to go ahead and solve. We'll solve for x first. Why not? We'll solve for x first. So looking at this triangle, we have x and, oh, I should have really made that triangle bigger. And 50 degrees is right here. W, oh, we can't use W. W is a variable, so we can't use it. There's 7. There we go. Beautiful. All right. That means the adjacent side is x and the hypotenuse is 7. So setting up the trig here, adjacent and hypotenuse, that's going to be cosine. So cosine of 50 degrees, let me give myself some room actually. Cosine of 50 degrees is equal to adjacent x over hypotenuse 7. A little bit of rearranging, we get x is equal to 7 cosine of 50 degrees. And I'm going to go ahead and I will tell you that this turns out to be, let's see, this turns out to be 4.5 when you round it to the nearest 10th. So I will write 4.5 up here. However, with these problems, you want to not round any intermediate computations if you need to use them later. So while my answer is 4.5, anytime I need to use x, I'm going to be using 7 cosine of 50 degrees. So this, let's see. This guy right in here is not x, it's 7 cosine 50 degrees. 7 cosine of 50 degrees from here to here. And maybe I should just pull that out. 7 cosine of 50 degrees. Okay. We now have enough information to solve for W. We can do that using trig, or we can use the Pythagorean theorem. The thing we have to be careful of with the Pythagorean theorem is we have to use exact values. So I'm going to show both ways. I'm going to show using trig, and I'm going to show using the Pythagorean theorem. All right. This is a 50-degree angle. W's down here, 7's up here. We have a hypotenuse of 7. We have an opposite side of W. Hypotenuse and opposite, that's going to be sine. So we have sine of 50 degrees is equal to opposite W over hypotenuse 7. A little bit of algebra, you get 7 sine 50 degrees for W. And if you plug that into a calculator, you'll get 5.4. Oh, why? So W is equal to 5.4. So that's using trig. But if you wanted to use Pythagorean theorem, you know that the side over here is 7 cosine of 50 degrees. And you can solve for W using the fact that W should be equal to the square root of 7 squared minus 7 cosine of 50 degrees squared. Now, sometimes you can use the rounded answer and still get the right answer. However, it's just not worth it to me. It's not worth it to me to go through all the effort to do a hard problem like this and then be off by a decimal point because you rounded somewhere along the way. I'd rather be safe than sorry. It's messy to put in the calculator, but it works. So if you plug this in, you're going to get the same thing. You should get 5.4. Solving for W. All right, so now we have W. So this side over here is 7 sine of 50 degrees is what I'm going to write for W. All right, now we need to find either U or Y. And we were given sneakily this important piece of information right here. X plus Y is equal to 27. And so let's do 3 here. So to solve for Y, if we know X plus Y equals 27, and we found X is 7 cosine of 50 degrees. So 7 cosine of 50 degrees plus Y is equal to 27. If you do a little algebra, you'll get Y is equal to 27 minus 7 cosine of 50 degrees. Plugging that in your calculator, you're going to get 22.5. All right, now we have U. So this distance here, this is 27 minus 7 cosine of 50 degrees. Oops, and that should have been in green. To solve for U, we are stuck with Pythagorean theorem. And it's messy, but we can do it. It's just a teeny bit messy. So we have this triangle here. We're solving for U. We know one of these sides is 27 minus 7 cosine of 50 degrees. We know that the top side is 7 sine of 50 degrees. This is a mess. So U is going to be equal to the square root of, and you know what? I'm just going to delete this picture because I'm going to need all the room I can get here. U is equal to the square root of 7 sine of 50 degrees squared. So A squared, because that's that part of the triangle. And then I need to do the other leg of the triangle. Squared plus 27 minus 7 cosine 50 degrees squared. When you're entering this in your calculator, you need to be really careful with especially like the square part here. When you plug this in your calculator, it's going to, so like you've typed in 7 sine. When you type sine in, it puts a parenthesis here. So if you only close one parenthesis and you put a square, it's only going to square the sine and it won't square the 7. So you need to be sure you put 2 parentheses and then the square. That'll mess up your answer otherwise. If you plug these all in and all is right and just in the world, you'll get U equal to 23.1. 23.1. And there it is. There are all those values. Ta-da! All right. Let's go on to the next one. It's a little messy, but it's okay. A house sits at the edge of a cliff. A fish swimming in the sea below the cliff is 1,000 feet from the base of the cliff. The angle of elevation from sea level to the base of the house is 25 degrees, and the angle of elevation from sea level to the top of the house is 30. Find the height of the house measured from the top of the cliff to the bottom of to the top of the house. Don't round any intermediate computations. Round your answer to the nearest tenth. Okay. So we're going to start with writing down what we know. We know that the fish is 1,000 feet from the base of the cliff. So we have 1,000 feet right here is how far that fish is from the cliff. And the angle of elevation from sea level to the base of the house is 25 degrees. So angle of elevation to the base right here is 25 degrees. Then the angle of elevation from the sea level to the top of the house, so up here, that is 30 degrees. What is the height of the house is the question. The height of the house. So that distance right there. So here's what I see. I see that we could find this distance right here, the height of the cliff. We could find this because we have a triangle and enough information. Furthermore, we have this like bigger triangle here, and that would give us the distance from here to here, the top of the house to the bottom of the cliff. So if we have both of this number and this number, the number we want is just the big number minus the small number. So that's what we're going to do. So I'm going to start with my 25-degree angle that tells me the height of the cliff. This is 1,000 down here. And I'm looking to solve for x. I have an opposite and an adjacent. Opposite and adjacent is tangent. So tangent of 25 degrees is equal to opposite over adjacent. X is equal to 1,000 tan of 25 degrees. Now, it says do not round any intermediate computations, so I'm going to leave that there for now. I know that that distance is 1,000 tan of 25 degrees right there. And it's hard to read, but that's what that distance is from here to here. Then I'm going to look at that bigger triangle with the 30-degree angle of elevation. Still 1,000 feet down here on the bottom. And now I'm looking for this distance, which is from the top of the house to the bottom of the cliff. Once again, we have an opposite and an adjacent. So we have tangent, opposite and adjacent give us tangent of 30 degrees equal to y divided by 1,000. Algebra, y is equal to 1,000 tan of 30 degrees. So this whole distance is 1,000 tan 30 degrees. So the distance we're looking for is the distance between the two of those numbers. So the house height is equal to 1,000 tan 30 degrees. Can I fit this in here? 1000 tan 30 degrees minus 1000 tangent of 25 degrees. If you plug that into a calculator, you should get 111.0 feet once you round. Feet. And that's that. All right, so those are just kind of some fun applications we can do with right triangles. Right triangles were one of the first big concepts that was developed in mathematics historically. Quite interesting. Actually, I went on a bit of a deep dive on Wikipedia for that. You might want to try doing that yourself. It's quite interesting because the the origins of a lot of the important things that we know today come from trigonometry and its humble beginnings. Anyway, that's it for the right triangle application section. And next section, we're going to start talking trig identities, which is one of my favorite things. We'll see you in that video. Bye.